now you can go home and do whatever you want.
Yeah. Alright, let's look at this one. I want to know everywhere the tangent line would be horizontal. What would that mean?
0.
What's 0?
The
The slope. Okay, if it's horizontal, slope of 0, how do you find the slope of a tangent line? Derivative. So I am just asking you, when is the derivative 0? So, our derivative would be what?
4x cubed times 12x plus 0.
Good. You guys know where that came from? Remember the 4 comes down, subtract 1 from the power, 6 times derivative of x squared is 2x. Derivative of 4 is 0. So we get 4x cubed minus 12x. And then we set that equal to 0. So what would we have to do to solve that?
Add over the 12x divided by 4 and root it. Oh, take out an x. What is happening?
Let's take out 4x.
I went way too fast for anything.
So we set them equal to 0.
X equals plus and minus that.
Ooh, I forgot the plus and minus.
Don't do that. It's not healthy for you.
So you think?
Doctors don't want you to know.
Okay. So we found all of the points when it would be horizontal. If I asked for ordered pairs, could you give them to me?
Maybe.
Like, if my x is 0, how would I get the y?
Oh, you're
Minus
to be
x
0.
is 0.
You put it into the derivative.
The derivative or the original?
Or sorry, the original. I said derivative, but I circled the original.
Yeah, I know. I was confused.
We put it into the original, get the point on the original curve, so that would be 4. If I put in the square root of 3. So, square root of 3 times square root of 3 would be 3.
Times 3
So
is
it would be
9.
9. Minus 18.
Plus 4?
Plus 4.
Which gives us?
Negative 5.
How did you do that so fast?
What if we put in a negative radical 3?
It'll probably still be a negative 5.
Because
Yeah.
it's got the positives.
Because when you take
Yeah,
a negative
'cause
to the 4th, it's
square.
positive.
And 4.
Alright. Very good. You kids came up with that faster than I expected.
Wow.
Alright.
That's dirt.
No, that is not what I meant at all. I didn't say I was surprised
I'm
you
surprised
got it.
you even got that right.
You're surprised we were able to do it?
Okay, moving on.
Moving on.
So- We did not get into exponentials yesterday. So, an exponential function is a number to a power. What's wrong?
They kept a wicked over there, and I was like,
So when you have like 3 to the x, or 4 to the x, or 5 to the x, those are all exponential functions. In calculus, just like with logs, we typically deal with natural logs. When we are looking with exponentials, it's typically the natural exponential.
For my pen.
Oh no.
So e, I've never really told you where e comes from. I just told you it's a number kind of like pi. It actually comes from the result of a limit. That's a fun little tidbit that I'm not going to assess you over in any way, shape, or form. But just in case you were curious, because I thought you might be.
How do we know it's from the limit though?
Well, how much time do you have?
No.
5 years.
45 minutes.
Approximately.
E is like a 2.7 approximately, so it's going to fall between 2 to the x and 3 to the x. But the whole reason we like this one is the derivative of it is nice. I'm not really, I mean, we can go through the whole, try to derive it from the definition. It's a little bit tricky. You really just need to remember, the derivative of e to a power is still e to the power. Okay, the proof behind that is a little more complicated. So this is kind of one of those rare times where I'm like, just trust me and this is what it is.
I trust.
So, the derivative of e to the x is e to the x. That is not true for other exponentials, like derivative of 2 to the x is not 2 to the x. There's more to it. And we'll get to those eventually. But this is the next one, because the derivative is just still e to the power. So, let's assume my function is e to the x minus x. I want to find the first and second derivatives, and since we don't do graphing calculators anymore in Python, I'm going to compare the graphs. So, what would be the derivative?
E to the x minus one.
Because derivative of e to the x is still e to the x, that's what I've told you. And derivative of x is 1. What is the second?
E to the x. So e to the x is like immortal. Just stays it.
And then if we did third, fourth, fifth, sixth,
Just keep.
75th derivative, they're all going to be
It
e
just
to the
eats
x.
all of its friends.
So it's never,
It never.
usually it ends up 0, but since it's e to the x, it'll not
Yeah,
be
because
Well, because we're not doing that
Unless there's
subtraction.
another e to the
Nonsense.
x question mark.
then you combine like terms.
You get 2 e to the x.
Okay, so using that, at what point on the curve y equals e to the t is the tangent line parallel to the line y equals 2x?
What?
And
So
it's
we have to
two.
think, yes.
And it's 2.
Parallel means same slope. Okay, if my line is y equals 2x, what's my slope?
2.
So I want to know when this tangent line would have a slope of 2. How do you find the slope of the tangent line?
Do the differential. Maybe not.
Yeah,
Slope
they
of
just
the
have, like,
tangent line is just your derivative. Derivative of e to the t is e to the t. So I'm just asking, when does e to the
I
t
meant derivative.
equal 2?
Whenever it's
E to the t never
whenever it's
equals 2.
squared.
E to the t never equals 2.
Oh, it's a
It
trick
does, but it's
question.
not a nice number. Do you guys remember solving exponential?
Oh, you gotta bring the
Oh.
2 e and t and yeah.
Oh, 2 to the t equals e. Wait.
No.
Oh,
T to the
we do the
E
natural log.
squared equals t.
They're like 4 realizations in a row.
Natural, dude. Don't do this to me.
Is it e squared equals t?
Natural log of 2 equals 2.
Oh.
So,
So it's 2
remember when we
equals-
solved exponential
Dude.
equations?
No.
Yes.
We could add logs on each side.
Sure.
And if you're dealing with e's, you would probably like to add a natural log because the natural log of
You
e,
see, they schlank
they
out.
cancel because it's like saying e to what power equals e, which is 1.
Equals 2.
T equals,
Natural
Natural
log of 2.
log of 2. Booyah.
And then we divide by the natural log.
Divide
Oh.
by-
natural log of 2 is a number if you type
Oh,
it in the
okay.
calculator. It's not pretty, but it's
Alright.
a number.
Okay,
Yeah.
I believe you.
If I ask this as a point, the natural log of 2 is like my x.
That's terrible.
If I wanted my y, if you plug that back in, what's e? We don't need a calculator.
Oh, already.
What's e to the natural log of 2? What happens when you have an e and a natural log?
They
They
cancel.
cancel, so it's 2. Booyah.
What? Okay.
Stop being that one Ninja Turtle, please.
Wait.
Master Splinter.
Using a lot of properties of logs.
So,
I just want to say that in the calculator.
to
is
the
not
natural
the same.
log is the same thing as the natural log of e?
Say that again?
Because it's isn't it the natural log of e to the t power? That's the one that we passed out the first time.
Because properties of logs, exponents come down. So this is like t times the natural log of e. Natural log is log base e. So this is the same thing as saying log base e of e. So it's like saying e to what power equals e,
Okay.
and that's 1.
So then the one with the natural log and the exponent.
Okay, this was a property, but if we wrote it like equal to x, okay?
Okay.
And you were trying to solve this. So if you wanted to get rid of the exponential, you could add a natural log on each side, right? Okay, properties of logs, so the exponent comes down.
The natural log of e cancels.
So you have the natural log of 2 equals the natural log of x. So x equals 2. So that's kind of the reasoning we gave back when we used that property.
Dude.
Dude. Arson went through like the 5 stages of grief there.
I didn't go through grief.
Let's look at this one. If I want the derivative. Okay, so we have to first
This is an awful.
rewrite this.
Hang on, e to the x is not the same. Like when we looked at this, x was not in place to number. It's only e to the x makes e to the x, not e to the 3 makes.
Right, because if it's e to the third, that's a constant, and this derivative is
Okay.
zero.
Yeah, I was waiting.
Okay,
I was a little.
the only thing we know how to do the derivative of currently is e to the x or x to a power. So how would I rewrite 1 over the cube root of x?
Yeah.
Good.
Yeah.
Plus e to the x plus x to the e plus e cubed. Okay. So my derivative. Exponent comes down. Keep the x. Subtract 1 from the power. Negative 1/3 minus 1. Plus, what is the derivative of e to the x?
X or e to the x, right?
Plus, okay, I have to think. X to the e. This is still x to a power, right?
Yeah.
So ex.
So e comes down. X. Subtract 1 from the power.
E minus 1.
Oh.
Beautiful.
Dude.
Plus 3e2.
Careful. E to the third.
Yeah.
Oh,
it's
wait,
e to
because
the
e is a
third.
number.
E to the x has a derivative of e to the x.
Oh.
E to the third is just a number. It's like saying 5 to the third. So there's no variable involved in there.
I forget e is not
So it's
just
a constant, so its
letter.
derivative is 0.
Shoot, bug.
I was wondering why you said that like that when I asked that question.
That's a decent derivative right there. Very decent. Let's find the second derivative now.
There'd be a lot of logs.
No.
No, was that just to show us how e's work again?
Yeah.
Okay.
It
That was
kind of a
just to scare
refreshing.
us away.
Then she just like coaxes us back, you know?
Let's look at this one.
This one is even
Oh, hey, these are the
more
last
than
ones
that
too.
problem on
Our
our-
last
Okay.
one.
Yeah.
Before we do anything,
Simplify it and put it into it.
Oh, yeah, we can do that.
okay, so
She just wrote it.
if I want to do this derivative, I can't do the derivative of things multiplied or divided yet, so we have to do a lot of simplifying first. I have x squared times the cube root of x. How would I write that as x to what power?
1/3.
Plus x times the square root of x cubed. That would be x to the,
Oh, 1/3 isn't. Oh, no, 3 seconds. Shoot, bug.
because remember it's the exponent on your x divided by the index on the radical. If there's no index written, it's 2. Minus, okay, this is squared. The square root of 2 squared is a 2. And then we have x
Oh, yeah.
to the second. On the bottom, if you have a power to a power, what do we do? So, I'm still simplifying. You might be able to jump ahead, but I'm going to go slow so everybody can stay with me. When you are multiplying, if the x is written each time, what do we do with our exponent? Add. Okay, remember, this is like 2 over 1. You have to have a common denominator. So 2 over 1 is like 6 over 3 plus 1 over 3, so that's 7 over 3. Plus, this is an x to the first. 1 is like 2 over 2. So 2 over 2 plus 3 over 2 is 5 over 2.
Wait, how is that over?
This, or,
Oh, because there's just it's square root. Got it.
yeah.
Okay.
Okay. This is all still over x to the 4/3. So I still cannot do the derivative because I'm still dividing things.
Bring it up to the top.
So, yes, we have to bring it up to the top. There's 2 ways to do it. You could bring it up as a negative 4/3 times all that, or you could think when I am dividing, what do we do with exponents? Subtract. So when I go through and subtract, 7/3 minus 4/3 will be 3/3 or just 1. Plus, okay, this one, I have to do 5/2 minus 4/3. Good fraction review. We need a common denominator if we don't have a calculator on a test. So this would be 15/6 minus 8/6. So that's. Okay, the next one we have 2x, okay, 2 minus 4/3. So 2 is like 6/3 minus 4/3. Okay. So far, all we've done is simplify, but we've taken a very nasty problem and turned it into a pretty decent one. With derivatives, even once we learn more, the more you can simplify early on, the better it will be. Simplify before you take a derivative. Always. It'll make your life easier. Now when I do this derivative, what is the derivative of x? Plus, okay, this one is 7/6x. If you subtract 1, so 7/6 minus 6/6 minus 2 times 2/3 x, 2/3 minus 1, so 2/3 minus 3/3, negative 1/3. We do not care anymore if we have negative exponents or anything like that. We don't have to rewrite it. That is our answer. All right.
Fractions are not my strong.
Questions there? So I want to talk about something. Tomorrow we are going to have a quiz before we move on. Because we have done several things. Now, the majority of your quiz, there's going to be, it's like 8 questions. Okay, 4 of them are from this stuff. So using what we've learned about derivatives. So rewriting your problem so you can do your derivative. The other 4, I'm going to ask you to use the definition of
And x plus h.
limit as h approaches 0.
All the homework was just,
Minus x over h.
So that was back sections 2.7 and 2.8. We were doing this. So it's actually, here, I'm going to give you lots of hints. There's 3 questions like this. Okay?
Okay.
Um,
Got it.
and then one.
there is, and if I asked you to write the equation of a tangent line, could you?
Yeah.
Probably.
You know, you have to do the derivative to get your
Find the
slope,
m or find the
and then use your point.
On the beat.
There will be 4 questions like the homework from last night and tonight, using our rules now to simplify it. And then there's one where I'm going to give you a graph and ask you to sketch the derivative. So you're looking anywhere the tangent line is horizontal, the derivative is 0. If the graph is increasing, your derivative is positive. And if it's decreasing, your derivative is negative. Okay? So 8 questions, you know what they are now.
Okay. Appreciate
And then you have time to work. So you hopefully have those done from yesterday. Then you don't have that many more problems. This is due tomorrow.